My name is Eduard Vainu, and I am head of operations in Hepta Airport. And what we do is we perform aerial power line inspection using drones. Hepta was actually founded in 2017 by one electric engineer and two aeronautics engineers with the purpose of inspecting the lines from above, as the standard during that time, at least for middle voltages, was to just walk alongside the line and perform visual inspection. And based on this, we realized that actually the view from above is far more accurate and precise, and also the data collection phase is a lot more simpler and safer in terms of you don't need to run away from bears, if we're, for example, talking in terms of Estonian nature. And yeah, we perform about 3,000 kilometers of power line inspections each month. And we have customers in about 40 different countries, pretty much across the globe. And we do all kinds of analysis, RGB, infrared, LiDAR, corona, whatever is actual for the specific power line inspection case. So our experience is quite vast in terms of local market. We have been inspecting for last 4 years the full Estonian middle voltage grid, and actually Estonia is the only country in the world where 100% of middle voltage power lines are inspected only using drones. And this approach actually enabled us to reduce the inspection cycle from 2.5 to 7 years for the customer, which means that instead of going every 2.5 years to inspect the lines, we can do it now in 7. How? This is based on our accurate analysis and prediction models. And so far, the customer is very happy, and we're also happy to present our success story. In Ukraine, our very first customer, we executed a pilot project for LiDAR mapping. Here's also a good opportunity for me to say a big thank you to our LiDAR partner, YellowScan dealer from Latvia, Ageo, and its head, Andres. They have been providing tremendous support to us in terms of getting the operations running, making sure that we have all the correct hardware and software, and the push that they enabled us to work cannot be overlooked. And now, following several years later, we can say that we have reduced the effect of defects on grid reliability by 3 times, which is just massive. And of course, in Portugal, which is probably the most interesting case, we conducted data collection of 1,000 kilometers per 1 month. And the core idea was here to prove that we can be just as fast as manned helicopters. And what we provide is 3 times less interruptions, 2 times faster results, and 100% less accidents, because if the worker does not need to walk under the line, then we can eliminate the risk. Also in Chile, we're implementing AI and digitization. In Slovakia, we have found 4.5 more time defects than helicopter has found. And in Finland, actually, we did a quite interesting LiDAR project using also YellowScan software. And the idea here was to perform nighttime flights over complicated areas, which are mostly very sparsely populated. And the idea was to find fallen trees on the power lines. So we took one line, what was about to be demolished, felled some trees on it. Of course, we did not know where those trees are actually situated. And at nighttime, we used our YellowScan mapper and also one YellowScan Ultra surveyor to collect point cloud data. And based on this raw point cloud data, a local partner, Esri, was able to create an algorithm which enabled to detect fallen trees on the power lines within seconds, therefore tremendously reducing the time needed for actually walking the line and finding out the defects. And especially if we're talking about Arctic areas where the snow is about a meter high, then this is a huge win. So again, quite interesting LiDAR project. But in Portugal, we were tasked to perform a pilot project where our work, quality, and data collection speed would be compared to manned helicopters. Therefore, we were given about 1,000 kilometers of power lines, which needed to be inspected. And the goal was to collect this 1,000 kilometers in 1 month. Therefore, we could state that if we could collect 1,000 kilometers in 1 month, then it's quite feasible to think that we could do 1,200 kilometers or 12,000 kilometers in 12 months. We were provided KML files with line names and the directions where the lines are going. And our job was to collect RGB data, infrared data, and LiDAR data. And LiDAR data needed to be processed into a very specific deliverable. These deliverables consisted of PDF reports based on the findings of regular defects, infrared, and also LiDAR measurements. A KML file, which can also be seen on the screen here, where you can just pretty much drag and drop it to QGIS or Google Earth, Google Maps, whatever is necessary, whatever is your favorite medium. And you could see where the defects are. They were color-coded as red. We could see where the vegetation was a little bit more severe than permitted. And also this enables the repair crew to have very easy access to the data in terms of going to the field and actually fixing it. The LiDAR cloud itself, as you can see here, was classified, vectorized, colorized as usual, classification based on pretty standard classes in terms of power line inspection, towers, ground, vegetation, roads, crossing lines, of course, and buildings, so that we could potentially detect dangerous buildings. And also the point cloud was colorized based on local standard, which means that the most dangerous areas were colorized as red, the less dangerous areas were colorized as blue, and potential risks that could be dangerous in the future were referenced as light green. And this enables the customer to have a really decent overview in our platform and take a look for themselves. And of course, final work deliverable as usual for power line maintenance companies is we delivered also an Excel table with precise coordinates representing the span length measurements, the wire sag, the vegetation risks, or how close was the vegetation per specific span, were there any illegal buildings, were some crossing wires too low or not. And this was all provided in one big package. The software we used for flight planning, of course, UGCS. I'm not going to go really deep into it because I know that they are going to present their case also. I just want to say that based on our experience, this is definitely the best flight planning software available, and we're really, really happy to provide our feedback sometimes and keep up with the features that are constantly being developed. So yeah, tremendously good tool for flight planning, especially when you're conducting LiDAR missions in difficult terrain. They enable us to load a digital terrain model as a base so that we could avoid the ground, or at least know what's the situation on the ground. And also many features that speed up our planning, like, for example, creating autonomously those loops every 1 kilometer or 1 minute of flight, so that we could wake up the inertial movement unit, so we don't need to draw those small boxes ourselves. And this again saves us a tremendous time, and also we can upload KML files so that we could do our flight plan and plan accordingly. And of course, YellowScan Cloud Station for georeferencing and LAZ generation. Again, very, very tremendously good software, and very happy to work with it, and the development behind it is obviously very customer oriented, and we're really happy to see that most of the developments in the software are actually the things that we really are looking forward to and could use to reduce our workloads and perform faster analysis by the end of the day. Of course, they are solid for vectorization, classification, and some measurements. And of course, in addition to that, we created some of our own algorithms so that we could generate the according PDF, Excel reports, and finally, all of this was uploaded to our proprietary software, UBERT, which we use for providing a better situational awareness in terms of, on one side, we provide a map view with the tower locations, the defects, and on the left side of the software, we usually provide an overview of images, are they RGB, infrared, or we can even present the LiDAR point cloud and perform all the according measurements there. So the hardware used for execution was a YellowScan mapper, which is, at first, we had a little bit of reservations in terms of could such a small unit be able to deliver the data accurately enough and fast enough, and would it be able to withstand the rigorous testing in terms of non-stop work pretty much in very hot and challenging conditions. And it could. We really pushed it every day in very difficult terrains, in dust. It was called into rain several times, and no issues, just perfect clouds pretty much. And if we want to talk about how many reflights we needed to conduct, then that number was also quite low. If we're talking about 100 or 1,000 kilometers, then about like 20 kilometers we had to recollect. But this was mostly due to the fact that the wire cover material was not very good in terms of reflecting the clouds back. So we had to corrigate our flights and fly a little bit lower and slower, and still we were able to collect those lines. And also, for the drone, we use DJI M300s, as this is one of the most easy to use and versatile platforms out there. And for additional safety, we also mounted a CSM radar for it, so that we could safely detect crossing lines, because this is a major issue or potential risk when you're conducting power line inspections, not to get caught in crossing high voltage lines. And yeah, the CSM radar does very well to mitigate this risk. In addition to that, for additional compliance and safety, we used parachutes and also a system which enabled us to cut the engine off. And this is just to make sure that if something goes really bad, we can cut off and land pretty much safely. And overall, when we were compared, we found out that we were able to collect the RGB and infrared data in 18 days, and it took us 28 days to collect the LiDAR data. So it's not actually 28 consecutive days. We had some days off also. We had about 6 days of rain where no flights were conducted. So therefore, if we would have had perfect weather, I believe we could have actually executed in 22 days, which is quite massive. The data was constantly being validated and processed by our analysts. So we had 30 days to collect the data, and then we had 30 following days to analyze the data, generate reports, and deliver it to the customer. And again, quite happy to say that in about 24 days, we were done with the analysis and report generation and moved on to the data upload and handover phase. And our data was compared to the one collected by a manned helicopter, and the differences were almost none. At first, we needed to adjust our algorithms a little bit to present the vegetation overview a little bit more clearly. But after that was done, our overlap between the helicopter defects and drone defects was about 98%, if I remember correctly. So the data is absolutely usable, trustworthy, and can be implemented on a bigger scale for power line analysis. And of course, by the end of the day, we like to implement AI-driven analytics also to develop some prediction models and perhaps give some extra value for the customer in terms of the analysis. But this is more of a long-scale work, so to say. But yeah, we had on-site 7 people, 1 project manager, 1 person for flight planning, 1 person to validate the data or create LAZ files. And today, I can actually say that with the new Cloud Station updates, we could have actually eliminated this 1 job position and done it with even less people present. We had 3 pilots for RGB and infrared, and we had 2 pilots for LiDAR. And this enabled us to have a pretty decent workload and also deliver the data. And yeah, so that's pretty much our use case in terms of data collection. And if I would want to talk about something complicated during that project, I'd say that the most challenging flight we executed was where we had an elevation distance over 1 kilometer on a span of about 400 meters. So yeah, we were quite nervous executing it, but again, happy to say that the drone was able to take it, and the data was good, and the data was accurate. So yeah, this is pretty much our use case regarding drones and YellowScan LiDARs. Happy to say that, again, they're really capable systems. We just tested the new mapper, and again, superb. Not much more to say, actually. It works very well, and we're really happy to continue this cooperation with YellowScan by testing products and also using them on field on a daily basis. And also, if I may, I'd like to pass on my congratulations to YellowScan on their 10th jubilee, and wish many happy years of delivering such awesome products that we're extremely happy to use. Thank you.